Couple important things. Today, I will be going through a special thing for you. And then after that, I'll go through test number 3 answers, which I will remove from the video. But anytime you want, come to my office hours, or if you can't, make the special arrangements for me to meet you on Zoom. After that, we'll do some lecture, and then I'll go through the lab that I posted last Thursday, but I'll go through and lecture the material that will help you do the lab, and it's not due until I think a week from today. I set it up. All right, well, in that case, what's the special thing I have to talk to you about? All right, can everybody see Chem 1211 Fall 2020 Extra Credit Project? Let me go through it. This is an extra credit project, 10 points. Yes, 10 big points. It's optional, but if you do it right, you'll get 10. Yes, 10. Do I have 5 fingers on each? I do. Anyways, 10 fingers. Dr. White's being goofy this morning. What do you have to do to get your 10 points? Well, the extra credit project is to create a list of ionic and covalent molecules found in ingredients lists of products that can be purchased. In other words, IE means that is, things that you can use in your daily life. You must find 5 different molecules that contain ionic bonds and 5 different molecules that contain, this is important, only covalent bonds. You can use 3 molecules from any one product. Well, that means you got to look at least 4 products to get all 10 molecules. You can do more. Now, to get your points, you must hand in, well, this is, I should have changed this. You have to upload a printed table with the product's name, the molecule's name, and whether or not, and if it's ionic or covalent. Be sure to put your name on the table. You'll get 1 point for each correct entry with a total of 10 points. Now, to make it interesting, you can't use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, which is also known as ethyl alcohol, sugar, sodium chloride, oxygen gas, or nitrogen gas. Anything else is you can use. Now, what would this look like? Table, first column, product. Now, this is an example of things you can't use, but I can use an example. If you look at Coca-Cola, you'll see on the label the first thing is water, and that's covalent. If you pick up a can of Campbell's chicken noodle soup or other of theirs, or anybody else's, you'll see on the label sodium chloride, and that's ionic. Now, ingredients must appear on an ingredients list of the product. You can't say, well, banana contains potassium or things like that, because guess what? I've never seen an ingredients label on a banana. These are the ones I've seen in the supermarket. And this is an optional project. You don't have to submit it. But if you do and do it right, you can get 10 points. That's like adding 10 points to any one of your test scores. This is 10 points to your bottom line. Now, this is important because this has happened over the years. Please note, this is an individual project. If you use items from another student's list, then that's cheating, which is against the academic ethics code here at COD. Don't, because if you do, I will follow what's in my syllabus for people caught cheating. 1, you'll get 0 points for this project. 2, I will send a letter to the Dean of Students and to the Dean of Math and Science stating that you were caught cheating. And that will go into your permanent academic record, which is not good. And too often I've seen over the years, 2 or 3 students will work together, use the same things and change the order and think Dr. White won't figure it out. Well, if you haven't figured it out by now, I have a photographic memory and I can remember that real quick. Now, hint, how do you find out if something's ionic or covalent? Well, use Google to find what the structure looks like. And if it has sodium, potassium, lithium, magnesium, or calcium in it, it's got an ionic bond, at least one. Now, you can use Google or you can ask your instructor. What does that mean? Well, if you email me your list before it's due, I'll check it and tell you, no, this is wrong, this is wrong, this is wrong. So there's no reason why any of you shouldn't be able to get 10 points. And hold on one second. I got to get something. Thank you for waiting. It's time for Dr. White's show and tell. Mouthwash. By the way, this is good stuff. And it's the scope of Walmart equivalent for scope at a fraction of the price, same thing. Now, if you look in the back, you'll see a label, which you probably can't read, but I'll read it for you. It says ingredients and glycerin. You can use that. It has sodium benzoate. Now, sodium benzoate, sodium. Oh, it's ionic. And there are a couple more, so I just gave you 2 points. Oh, by the way, if you don't want to buy stuff, and if it's safe enough, even though now with the pandemic, I don't know about it, but you can always go to the store with your cell phone and photograph the labels and come home and check it out. You don't have to buy anything. And stores don't get upset when you look at labels or your photograph labels. I've done that. And so I can get at least 3 points from this product, because any product, you can only get 3 molecules. And sodium benzoate, glycerin, ooh, there's another couple you can get from your, I'm not going to give it away. You got to look on your own. So this is totally optional. Hold on, I'm going to put this away. I'm back. This way, oh, by the way, now you know why my breath is so nice, fresh, and minty every time we meet. Can't you tell? Why, that was even lame for Dr. White. Sorry, not really. All right, so you should be able to get 10 points easy. Remember, if you come to my office hour and show me your list, or if you email it to me in advance of the due date. The due date, now this is one important thing. The due date is December 3rd, 2020. That's the day of test number 4, a Thursday. No late projects are accepted, period. This is what I always do. So be sure to get it in on time, or better yet, early. It's set up in the assignment area of Blackboard for you to do. And if you do it right, you can get 10 points. I like that, 10. All right, any questions about the extra credit? If you do have a question, always feel free to come to my office hours on Monday and Wednesday night. If you can't come to my office hours, like you're working then, and you really need help, email me. We'll work out something. That's the nice thing with Zoom. You don't have to worry about is he at COD or not. I'm at my COD North classroom, otherwise known as my office in my home. You can see my printer there, a couple of hard drives, project stuff. Anyways, let's get to work. All right. I'm going to go through test number 3 answers. There are 2 versions, B and C, and I'll flip back and forth because B and C were not all the same. That was done to see if I could catch someone cheating, and unfortunately I did. So please don't cheat. It's the one thing that really gets me upset, and I work very hard to try and catch people who cheat because they shouldn't. But everybody looks like did really good. Thank you. And I guess the extra time I spent last week reviewing some stuff helped too, which is why I did it. All right. All right. Remember, if you have any grading questions, either come to my office hours or email me. Now is not the time to say, why'd you take off 1 point here or there? However, there's no such thing as dumb question. If you ever have a question of why I did take off points, ask me, and I will explain it. Either I did it right or I didn't. If I did it wrong, I'll correct it. And the last time I checked, I don't walk on water unless it's frozen. Even then, I stay off it. If you don't know the reference to that, think of religion and who's someone who could walk on water who's perfect for that religion. Guess what? That's not me. Oh, even though when I was very young, right around Christmas time, especially, I thought I was the Messiah. Why? Because when I was young, I'd go in the kitchen and say, Mom, is dinner ready yet? And she'd look up at me and say, Jesus Christ, are you in here again? True story. Like that one. And I don't even charge extra for this great humor. Remember, don't forget to send your donations to the Save Dr. White Foundation, care of your local post office or somewhere. All right, let me do some cleaning up here. That's not what I want. All right. Everybody see K equal AEQ and reaction completeness? Thank you. All right. I talked about this on last Thursday. Remember, the equilibrium constant is this mathematical equation for an equilibrium reaction. Remember, equilibrium reaction is when you have a reaction that you have both a forward and reverse reactions that happen at the same time at equilibrium. The forward and reverse rates are the same. And I mentioned the magnitude of K equilibrium. We went through some examples When K equilibrium is large, greater than 1, that means you have more products than reactants. When it's smaller than 1, that means you have more reactants than products. And we went through this, and we'll do more. All right. Warning, you're going to hear Dr. White's north side of Chicago French accent. In other words, I don't speak French that well. And when I use the name this next person and their principal, twice now I've had students from French-speaking countries, mainly Africa, who started laughing and corrected me. And I thanked them and I said, well, I'm still going to use my north side Chicago accent, French accent. All right. Now, at first glance, and I better do this first, everybody take a deep breath, let it out, take a deep breath, let it out. You're nice and relaxed. Next thing is going to be a little challenging at first. Relax, but with a little practice, you'll get it. All my students in the past have. Let's talk about the Chatelier's principle. And you can all laugh how I pronounce his name wrong, but Chatteler's principle, and don't write this down because I'll explain how to use it. I'll never ask for a definition. When a chemical system at equilibrium is disturbed, the system shifts in direction that minimizes the disturbance. Another way of saying that is if a stress, changing condition, is applied to a system in equilibrium, the system will adjust, change the position of the equilibrium in the direction that best reduces the stress imposed on that equilibrium. Huh? Well, let me explain. Let's talk about the effects of concentration on equilibrium. See board. Ooh, I better change screens on you. Uh-oh, I don't have it open. Hang in there, sports fans. All right, everybody see the whiteboard? It should be blank. And through the magic of computer drawing tablets, everybody see the equilibrium, A plus B. All right, thank you. Now, question is, now let's look at this problem. What happens to the concentration of A and C if I add, and 3 points C, more B? Now, at equilibrium, there was a certain amount of A, certain amount of B, certain amount of C, certain amount of B, and when you put it into equilibrium constant, you got KEQ. Now, if I add more B, there's too much B. Oh no, it's not all upset. And now it's going to lose its Chatelier's principle. And how does that do that? How does it get rid of excess B? Well, there's only one way. Remember, when you react two things together, they're consumed. You have less. If you have a pie, like an apple pie or actually a French silk pie, I need that like a hole in it. But if you had a French silk pie and you ate half of it, and after you ate half the pie, do you have more or less of a pie? And the answer is you only have that half, and you have less. Why? Because you've consumed some of it. You pigged out, but you had a good time. French silk are the best. But that's what we mean by when something is consumed, reacted, your concentration, how much you have, goes down. So the Chatteler's principle says we have too much B. How do we get rid of B? We reacted with A to go this direction. And when that happens, what happens to the concentration of A? Well, if you react it, it's going to be consumed just like the French silk pie, and the concentration will decrease. Now, A and B react. What do they make? More C and D. Well, if you make more of something, guess what? The amount you have will go up. Therefore, C will increase. And that's the Chatteler's principle. When you add or subtract things, the equilibrium will shift in the direction either this way or this way to get rid of that stress. And what was the stress? By adding more B, we've changed the concentration and we've got to bring it down. How do we bring this down? By reacting B with A. When something reacts, it's consumed. And when this is consumed, reacts, this will react with it. Therefore, that's why A decreases. Now, when A and B react, they go, hold on, let me clean up this mess on the screen. If A and B react, they're going to make more C and D. Well, if you make more of something, the amount you have will increase. And that's the Chatteler's principle. Oh no, I'm looking at the clock, and I think we're going to take a little longer break because instead of me rushing ahead and doing another one of these, we're going to take a break. And guess what? Let's take a break. I'll give you an extra minute. See, am I nice today or what? And I'll see you at 10:55. That's when the big hand is on the 11. For those of you with digital watches, 10:55. See you in a little while. Time to come back. Sorry, I'm a minute late. I got caught in rush hour traffic in my house. Not really. All right, everybody back? All right, let's go back to what we were talking about with Chatteler's principle. Remember, with Chatteler's principle, a system under stress shifts one way or the, they went that way, shifts in the direction to reduce the stress on that system. Now, I should remind you, your lungs, and I think either your kidney or liver, I've got to look that up, I forget, operate using Le Chatelier's principle. And that's how it gets the oxygen into your body, in your lungs, and the carbon dioxide out of your body when you exhale. And therefore, think about it, you're using chemical principles to stay alive. All right, quick check. Everybody see the whiteboard? Okay, thank you. All right, let's do B. What happens to the concentration of A and C when you remove some B? So if I remove some B at equilibrium, there was a certain amount of B. Let me clean this up a little. So at equilibrium, there was a certain amount of B, but I've removed some, so there's not enough B. When you remove it, the concentration goes down. So the question is, how do we make more B? Well, to make more B, the only way you can make it is by C and D reacting. Well, if you make more B in that way, you're going to make more A. Therefore, the concentration of A will increase. And what happens to the concentration of C? Well, how did you make more B? C and D reacts. Whenever two things react, the amount you have is consumed. That means it gets lower. Just like the French soap pie, if you consume some of it, you have less. Therefore, the concentration of C would decrease. And I'm going to let you have some fun because I don't want to steal all the fun. That's not being polite, host. So the question is, for this equilibrium right here, F plus E plus F makes G plus H. What happens to the concentration? Remember, in brackets, that means moles per liter, the concentration of E and H if I remove some G. your turn to have fun. By the way, hint, use the Chattelier's, excuse me, principle. And when you think you're done, give me a thumbs up. Give a little more time. I see some of you are still working. Oh no, I can see smoke coming out of some people's ears. Not really. All right, I think is everybody done? You're done. Let's do this. Question is, what happens to the concentration of E and H if I remove some G? At equilibrium, there was a certain amount of G. Now, there's is less G, and therefore the equilibrium and all the reactants say, oh no, we don't have enough G, and we need to make more G. That's the stress. So how do you make more G? Well, there's only way you can make more G. That's when E and F react to make G and H. Because you just can't make one thing, you make everything on the product side. So if E and F react, when something reacts, it's consumed. Just like the French silk pie, when it's consumed, you have less. Therefore, the concentration of E decreases. Now, E and F made more G, but they also made more H. When you make more of something, the amount you have, guess what? Increases. Let's do another one. These are fun. What happens to the concentration of E and F if I add some more F? How do I do that? Well, you have these in a beaker, take an eyedropper of pure F solution, and you have to add some drops of it. And now it's your turn to have more fun. And when you're done, give me a thumbs up. Those of you are quicker than the other people, please be patient. I try and give everybody time to finish the problem. All right, anybody need more time? Going once? Going twice? Done. All right. Question is, what happens to the concentration of E and H if I add more F? Well, let me clean up the screen a little. At equilibrium, there is a certain amount of F. Now, when we add more, the concentration of F is higher. And it's higher than it should be. And the stress is, oh no, there's too much F. We've got to get rid of some F. Well, how can you get rid of F? The only way you can do that is E plus F reacts to make more G and H. Well, if you lower the concentration of F because it's being consumed, same thing will happen to E. And it will decrease. Now, when E and F react to get rid of some of the excess F, you make more G and H. When you make more of something, you have more of it, and the amount you have, the concentration, will increase. Now, interesting enough, after it shifts back and forth and gets back to equilibrium, you'll have new amounts of E, F, G, and H, but it will still equal the equilibrium constant, whatever that is. And that's the Chatelier's principle. Again, I'm using my North Side Chicago. Now, I'm not sure what you mean by what are you saying after the word if in the question. Not sure what you mean by that, Camille.
Up above where it says 3 points each, right below, what happens to E,
All right,
D, and F?
all right. This right here, where I'm got the cursor under, what happens to the concentration of E and H if and then I remove some G. Or
Oh,
add,
okay, that's an I. Okay, thank you. If I, okay, thank you.
by the way, that's a good question. I better practice my penmanship. Remember when the teacher said, well, write that 10 times so you do it right. All right, let's move on. And thank you for your question. All questions are good questions. Now, one of the things I didn't mention, I better do it now. Say you have a reaction, A plus B make water plus C. And what you do is, in the reaction, you remove the water by something called the vacuum distillation. And what it does is it's forced to equilibrium this way and makes the reaction go quicker. And Dr. White's done that both in a lab and in chemical plants. And later in the semester, I'll show you some pictures of me in a chemical plant. And that plant, they did that kind of reaction where we removed water to make more C. And how much water? Well, for some of those reactions, where if you're starting with about 160,000 pounds of total chemicals, A and B, you make 10, 15,000 pounds of a couple thousand gallons of water, which you remove. And that reduces the reaction time by a lot. So this is a procedure. Not only does the Chatteler's principle work in your body, but it works in the chemical companies too. Now, unlike the equilibrium constant, which doesn't involve heat, let's look at the effect on a change in equilibrium, the effects of the change in temperature on the equilibrium. And remember, exothermic gives off heat. Endothermic takes in, or you have to add heat. And what does that do to the equilibrium with the Chatteler's principle? Good question, thank you. Now, before I go on, let me remind you, when you put a reaction in boiling water, you add heat. When you put a reaction in an ice bath, guess what? You remove heat. So let's take a look at the following. If we look at this equilibrium, A plus B is equilibrium with C plus D plus heat. This is an exothermic reaction. How do you know? Because heat is on the right side. Now, I'll print if I'll let you do this first one. A, what happens to the concentration of A and D if I remove some, oh, hold on. That, oh, mistake. I remove some C. Your turn. And when you're done, give me a thumbs up. All right, I think everybody's done. Is everybody done? I think so. So if we look at this, at equilibrium, there was a certain amount of C. We've removed some. You need to replace it. Because if you remove it at equilibrium, there was supposed to be a certain amount. Now there's less. You need to make more. How do you make more C? The equilibrium shifts this direction. A and B react to make more C. Well, if A and B react, when something reacts, you're going to have less of that. Therefore, the concentration of A will decrease. Now, A and B react to make more C. Well, when you go this direction, you're going to make more D also. And when you make more of something, guess what? The amount increases. So you have an increase. Now, let's do B, and this one Dr. White will do. And the question is, what happens to the concentration of A and D when you put the reaction in boiling water bath? In other words, hot water. Oh, look, someone wrote on the screen something important. Remember, hot water adds heat, ice bath removes heat. So at equilibrium, and hold on while I do this, at equilibrium, there is a certain amount of heat. By putting it into boiling water, hot water, we've added heat. And now it has too much heat. And it says, woe is me. It really does say it, not really, but it sounds good. I have too much heat. I've got to get rid of heat. Well, how can you get rid of heat? There's only one way. C plus D plus heat make more A and B. Because this way the heat will be consumed and you'll have less heat. So the equilibrium shifts, shifts to this direction. So if heat is being consumed by reacting with C and D, guess what's going to happen to the concentration of D? It's being consumed when it reacts with the heat, and therefore the concentration will decrease. Go down. That's why I have the down arrow. Now, since C plus D plus heat are going this way to make more B and A. If I'm making more A, guess what? I'm going to have more of that. And the concentration of A will increase. And that's how you do it. Oh, let's do another one. See, all right, number C. What happens to the concentrations of A and D if I put the reaction in an ice bath? Remember, hot water adds heat, ice bath removes heat. Your turn. Remember, this is tough, but you can do it. I have faith in you. And when you're done, give me a thumbs up. And don't forget, Thanksgiving is almost here. So make sure you line up your own Zoom Thanksgiving dinner with friends, neighbors, and loved ones. Anybody need more time? I'll give you 8.7 seconds more. Nine, 10, 11, 12. Bonus time is done. All right, let's do this. Question is, what happens to the concentration of A and D when I put the reaction in an ice bath? What is an ice bath? It removes heat. At equilibrium, let me clean this up. At equilibrium, there was a certain amount of heat, but this removes heat. And the equilibrium says, oh no, I don't have enough heat. Somebody took my heat away, the ice bath. How do I make more heat? Well, the equilibrium shifts this way. A and B react to make more C, D, and heat. So what happens when two things react? They're consumed. When something is consumed, the concentration decreases. I'm over here right now. Sorry about this super busy slide, but hopefully you get it. So A and B react to make more heat. Why? Because you had removed some of the heat, and that's the Chatteler's principle. Well, if A and B make more heat, they also make more C and D, because the reaction equilibrium has shifted to that way somewhat. And therefore, the concentration, what you make more of, which in this case D, will increase. And that's the Chatteler's principle. Now, if I look at the clock, guess what time it is? It's time to go to the lab. Everybody put on your safety goggles and put on your gloves. Actually, if we were in COD, you would be doing that now. Now, the lab that I posted last week is not due until next Tuesday, but I'll talk about it now. Why? Because last week you didn't know about the Chatteler's principle. Everybody see the Chatteler Lab 11 on the screen? Thank you. All right, so today's lab is equilibrium reactions and a Chattelier's principle. An equilibrium reaction is when you have two opposing reactions with the same and forward reverse reaction rate. Now, consider the equilibrium. There are two types of classification of equilibrium. One is exothermic and the other is endothermic. Exothermic is a reaction which gives off heat. And if we look here, this is an exothermic reaction because on the right side, it gives off heat. Now the other type is endothermic equilibrium, and you have to add heat. And heat is on the left side for an endothermic reaction. An important principle for equilibrium, like I just taught you, is Le Chatelier's principle. Even though I can't pronounce his name correctly, you get the picture. And Le Chatelier's principle, like I said, if stress is applied to a system in equilibrium, the system will readjust the equilibrium position in the direction that best reduces the stress. In this lab, you'll be examining the effects of adding reactants and products on the equilibrium, also adding heat and removing heat on the equilibrium. When you do this, you will be able to determine if a reaction is exothermic or endothermic. And what we mean by that is which side do you put the heat? Now, the first one you're going to look at, part one, this is a cool reaction, is cobalt ion equilibrium. And here we have cobalt tetrachloride, -2, is blue. And it reacts with 6 water to make cobalt hexachloride plus chloride anion, and this is pink. So you can tell by the color which side it's shifting to. When it's pink, it shifts to this side because you're making more of this. When it's blue, the equilibrium is shifting to that side. And you'll be using the Chatteler's principle to find out either on this side or this side, which side do you put plus heat. And it could be either endothermic or exothermic. And what you'll do is the following procedure. You'll add 2 milliliters, you'll see this in the of the cobalt chloride solution to a test tube, and you'll determine the color. You'll add 5 drops of DI water, and when that happens, you're increasing the amount of water, so you should shift the equilibrium that way. It should turn pink. And then you'll add 5 drops of 12 molar HCl. This adds Cl minus, and you'll figure it out. Then you'll put the beaker, the reaction beaker of boiling water, which adds heat. And then afterward, which is a cool reaction to do in the lab, I'm really sorry you're not doing it, you'll put it in an ice bath, which removes heat. And in each case, you'll record the color. Then when you're done, it goes in the waste beaker. Now, it turns out I have found a YouTube video for this. Let's take a quick look at it. You can do this in your leisure. And notice they have the same equilibrium. They're all the same at the beginning. And let's look at one. They're going to add water. Look, the color changed. Next, I'll add some Cl minus. Ooh, it went blue, where this one stayed pink. Is that pretty? Dr. White likes when things change color. It's chemistry in action. Now, look what happens when you put these in hot water and cold water. Look, the hot water is going blue, while the cold water stays pink. And that's the thing. Now, notice I have the data for you already, and you can watch it on YouTube. Now, what you have to do in the question for part one is, when you add water to the test tube, what color is the solution? Use the Chatteler's principle to explain this. Use the equilibrium. Now, when you put the test tube in an ice bath, what happens? Use that. Finally, number 3, write the equilibrium for part 1 and please include heat on one of the sides. Now, secret, don't tell anybody I'm being nice to you. It'll ruin my image around here. To make your life just a little easier, I have done the following. It's the chemical equilibrium help sheet from Dr. White. And for part 1, adding water increases the H2O, adding Cl2 increases, adds Cl minus, putting in boiling water adds heat, put it in ice bath removes heat. Now, here's the big part. Note, boiling water shifts the equilibrium to the side without heat. Boiling water shifts the equilibrium to the side without heat. You can tell that which side by the color. And ice bath shifts the equilibrium to the side with heat, because your ice bath is removing the heat, so you want to make more heat, so that's why. Same thing here, you're removing it, so shift it away from the side with heat. And this sheet, and also I'll talk about part 2 in a second, we have is located in the assignment area for you to download along with the lab. And this will make your life a lot easier. Shh, don't tell anybody. Now, there's a second equilibrium I want you to look at, and that's ammonium chloride is an equilibrium when you're in water with ammonium ions and chloride. Now, on this side, the ammonium chloride is a solid in water. On this side, it's clear. And what you'll do is add the solution to the test tube. If there's a solid, check and see if there's a solid present or not. Then add 5 drops of HCl. Remember, HCl increases the chloride concentration, and therefore you should shift it this way and see a solid form. And then you'll put it in boiling water, and then you'll put it in an ice bath and look for what happens. Now, what you have to do is answer some questions and figure on this reaction, just like the other one, is it exo or endothermic? Is heat on this side or is heat on this side? And I'm not going to tell you. You got to figure that out yourself. But here's the data. And this one, oh, I thought I had one. I don't have a YouTube. I'm going to have to look for one. And remember in part 2, adding HCl, 12 molar HCl, increases this chloride concentration. Put it in boiling water, adds heat, and putting in an ice bath removes heat. If you see a solid, it's gone to the left. If you see no solid, it's on the right. And remember, for this one also, boiling water shifts the equilibrium to the side without heat. Remember this, you can download too. And the ice bath shifts the equilibrium to the side with heat. And with that, my timing's pretty good. I'm going to let you out maybe a whole minute early. So with that, it's time to say goodbye for today. Don't forget, Wednesday night, if you have questions, always feel free to come to my office hour. Also, don't forget to do the practice problems for, well, we're almost done with this chapter. And with that, I'm going to say, gang gesund, be healthy. It's dangerous out there. Don't forget to wear your mask. Be healthy, gang gesund, and goodbye.